Hello students, today we are starting the chapter machines and I hope everybody very attentively will listen the lecture. So first thing is that what is a machine? Students, I think in class 7 or 8 you learn about the definition of machine and basically lever, which is a type of machine, okay, and pulley, lever, what is the definition, what is force multiplier and speed multiplier, that basic concept you had, okay. So I hope you can use that concept here also, okay. So just first thing, what is a machine? Any things, any object which can makes our work very easy, that is machine, okay. Any instrument that makes our suppose we are doing something, okay, and any instrument make this work easier, that is machine, okay. So whatever we are doing everyday life, even our hand is also a machine, one kind of, okay, because it will doing easily to do any work you can use using hand, so it will also act as a machine. So whatever our leg also, raising the foot, you are just raise your foot from the ground, that is also uh, structure of a machine, act as like a lever, okay, and the lever is a part of machine, okay. So that's why this topic is very important. Now students, the basic introduction you can see here, that in our common experience, read the chapter properly, okay. It easier to open a nut by using a wrench rather than by hand, okay. So wrench is a machine, understand. So students, you will read the chapter, but I am explaining the main thing, okay. So functions of your simple machine, and that machines you also called as simple machine, okay. So what is, suppose here also some example you can see, then you can understand wrench, pulley, crowbar, okay, everything, okay, that make our make our work easier, okay, that is called a machine. So now come to the thing how it will make our work easier, okay. There is some different process. First you can see that act as a force multiplier, okay. Force multiplier means a lift in lifting a heavy load by applying less effort, means you are applying effort less but load is more. By this the system will be like that. That there are mainly three terms related to this machine. One is load, effort and fulcrum, okay, that I am coming now, coming after some time. So just remember this thing. One, you can say it as a force multiplier, or you can say it as a speed multiplier, okay. There you can see at the fourth point you can see it as a speed multiplier, and 2 on 3 combiningly you can say that change the direction of effort, okay. Here you can see change the direction of effort, and here the change the point of application of the effort, okay. That you are applying point some other place, suppose in bicycle you are walking, and your effort is somewhere you are applying, but two wheel is there, okay. So here you can see that the rear wheel of the cycle is rotated by applying effort on the pedal. Here you are giving effort, but the rear wheel is moving by the to the on the pedal attached to the toothed wheel, which is joined to the rear wheel, okay, with a help of a chain is there. So point of application is here, but function is running here, okay. So I hope now you can understand that change the point of application, some machine will work like that way, some machine can work like a speed multiplier, okay, and some working like a changing the direction of effort, okay. Suppose in some way it is acting the effort straight rightwards, but it can change it to the straight upward to make that easier, okay. Maybe if you give the upward force, okay, all in assumption I am saying to make you understand, then the less force, less effort the work will be done. So by this way some machine will work like that way. So these are the four process generally, okay. Now students, move to the next portion. There you can see some technical term, load, effort, mechanical advantage, that you need to know, okay. Mechanical advantage, that load by effort. Mechanical advantage is also known as load by effort. Now students, just simply I am moving to the next page. Whatever you need, that I am explaining right now, and the latter portion I will explain later, that velocity ratio and that other things. Okay, directly I am coming to the lever right now. Okay, what is first? Lever is two type, class 1, class 2 and class 3. Now students, I have prepared a note. I am moving to that portion start directly. You will prepare a note like that in your copy. Okay, so here you can see that machines means levers. I directly come, lever is also a simple machine. There you can see lever means a rod. Okay, a rod or rotate about fulcrum, means somewhere there is a fulcrum. Fulcrum is the attach point where the lever attached, and one portion load is there, load, and another. So fulcrum is designed by the denoted by the sign F. L is load and F means effort. E means effort. So just remember like this way, that a lever is arranged in this way. Okay, this is a special type of lever, but I am giving the introduction of lever. There will be a load, there will be a fulcrum, and there will be a effort, means force is applying somewhere. Okay, so this is called is you can say that it is a simple construction of lever. Okay, so lever is what? A lever is a rigid, straight or bent bar which is capable of turning about a fixed axis, and that fixed axis is called mechanical advantage. Okay, so I am sorry, fulcrum, that fixed point, and mechanical advantage is known as that. And students, you remember this thing, from the fulcrum to the effort where you are applying the effort, that portion is known as the effort arm, and from fulcrum to the load is called load arm. Okay, remember this thing. And mechanical advantage means how the machine is working, that is given by fulcrum by load. Here this portion you can see, mechanical advantage is equal to effort arm by load arm. Effort arm denoted by EA, load arm by LA. You just copy it in your copy. Okay, you just write it in your copy, that effort arm EA and load arm LA. So EA by LA is equal to mechanical advantage, and it will act in three way. If mechanical advantage greater than 1, means when it will be greater than 1, when EA greater than LA, means EA means effort arm greater than load arm, then the value will be greater than 1, and in that case the machine will act like force multiplier. Understand? You know what is force multiplier? Okay, means it will change the direction of force, and in less effort it will do more work. That is called force multiplier. Okay, and if the mechanical advantage less than 1, means when load arm is more than the effort arm, that time it will act like a speed multiplier. Okay, and similarly when is equal to 1, means when it will in middle, fulcrum, if fulcrum middle, then this side effort and this side load. If fulcrum middle, both distance same, that means load arm is equal to effort arm. In that case the mechanical advantage is equal to 1, and in this time the machine will work like that, change the direction of effort. It will act like this way, like seesaw. Okay, so now students, moving to the examples for better understand of this chapter. You can see there is three types of lever. First one, you can see the fulcrum is at the middle. Okay, and effort and load is the different side. Okay, that fulcrum middle means it can move right side or left side. That means for class 1 lever, mechanical advantage can be greater than 1, can be less than 1, or can be 0. Understand? Sorry, can be is equal to 1. Okay, understand? Because fulcrum can move right side, left side. If it will move left side, load arm will be lesser. Okay, and if it will move left side, if it will move, E to F distance will increase. That means effort arm will increase. If effort arm will increase, that means mechanical advantage will be greater than 1. And if it move right side, then load arm will increase. Okay, load arm increase means it will be less than 1, means it will act like a speed multiplier. Okay, and if is equal to 1, it will change the direction of effort. So first class 1 lever can act in three different way. Okay, it can provide three different type of mechanical advantage. And what is this all things, all these force multiplier, speed multiplier, that thing, students, one by one when we will follow proceed, you understand. Okay, now students, come to the class 2 lever. You remember this class 2 load is middle. Okay, so just first remember this general formula FLE. Okay, because sometime lever construction used to come, so you can draw it. FLE. F means fulcrum middle, L means for class 2, L means load middle, and this time E means effort middle. Okay, so remember this simple thing. Now students, in second class lever you can see load middle, L means load middle. Okay, then right side effort and left side fulcrum. Now student, from fulcrum to effort is effort arm. In this case you can see fulcrum one side and effort another side. That means effort arm is always greater. Where you will put the load, anywhere you can put the load, but effort arm is always greater. That means this lever always act as a force multiplier. Okay, I hope you understand. This lever always act as if, because always its mechanical advantage will be greater than 1, because its construction is like that. Similarly, class 3 you can see one side load, another side fulcrum, means load arm is always greater. That means its mechanical advantage always less than 1, and it can act as a speed multiplier. But students, class 1 lever can act as a speed multiplier, whether force multiplier, or whether change the direction of effort. I think students you can understand very properly 3 types of lever. Now coming to the example, which are the first class lever. Students, in your copy book, so there is very nicely all have given, but some structure I have draw. Suppose you can see a seesaw. Here you can see, if the seesaw is like this way, it has constructed, you can see load arm and effort arm is similar, means fulcrum is the middle, EA is equal to LA. Okay, that means fulcrum mechanical advantage is 1. That means it can change the direction of effort. Okay, if one side giving the effort, another side simple load will go up, and shape another side, if there is the effort is given, here the load will go up. Okay, so simultaneously it will takes place, it will change the direction. Okay, and next move, then move to the next example. Now coming to students, here second example, that is, it is a scissor. Okay, scissor is a speed multiplier. How? You see here, if the middle is fulcrum, here is the your finger will be there, and the loader means load is here, it will cut by here. You can see in scissor that where we used to put our finger, that portion and right portion is longer, this portion is longer than the here this portion. Why? So hence, where the effort we are giving, that effort arm is less. Okay, effort arm is very less than the, but fulcrum is middle. Student, first class lever means fulcrum will be middle. Always remember that. Fulcrum middle means first class lever. Okay, so here the fulcrum to middle, then right side that are longer. Okay, now first fulcrum middle means first class lever, but its load arm, here the load means load arm is greater, always greater than the, so hence it is a speed multiplier. Speed multiplier means, students, is, you know, here by less amount force, whatever the force effort we are giving, but it will do it more wide area, it will cut. Okay, if you just suppose, if you turn a cloth with your hand, okay, it is quite odd. Okay, then the scissor will wide area you can give, suppose long scissor. So if you are turning by your hand, then what happens, you will turning from one side, where you are giving the effort, only that portion will turn. But in your scissor, if you put the scissor, you can see that much area will cut together. Understand what I am saying? That is the speed multiplier you can see. Okay, means a more area it will cover. Okay, it is covering a more area, that's why. Okay, in less effort. Students, more properly you can say that displacement of load, which is written in your book, you read it, displacement of load is more as compared to displacement of effort. Okay, suppose this is the total cloth, so if you displace your effort up to this portion, but entire portion will cut. Okay, so displacement of effort is less than the displacement of load. Okay, that's why it is called speed multiplier. Understand? So I think you can understand right now these 3 examples. Now moving to your book. Okay, another one example, crowbar. It is important. Sometimes question used to come. That's why I draw it, and you will draw like this way and explain on this way. You write in your own words in exam. Okay, you will write like this way. Suppose a crowbar is bent. Okay, straight rod, it has bent like this way. You can see the structure. You will draw like this way. Okay, I am drawing is again here. Suppose there is a load. You just bent a rod over here, you put the rod over here, there is a support, that support is act as a fulcrum, you know. There where the support is there, that is the fulcrum point, joining point or any support. Okay, so support means that is act as fulcrum. Here it is load and effort we are providing here. It is widely used in our life nowadays, now every day. Okay, we use it. So here you can see that is called crowbar. That when you put the effort, you can see effort arm is very longer. So effort arm is longer than the load arm. Load arm only this portion. Okay, only this portion. Fulcrum to load. Always remember that from fulcrum we will calculate the arm. Fulcrum to load, load arm. Fulcrum to effort, effort arm. So mechanical advantage always greater than 1 means force multiplier. So students, I think you understand up to class 1 lever I complete today. Once move to the book, then I will complete it. Here now move to the book. Here is the page. This portion you read it, you check the book and you read it. Here it is the kind of lever, class 1 lever. Okay, here class 1 lever, and here all the thing written, force multiplier and all other thing also has written over here. This portion also, that the displacement of load is more, a pair of scissor, everything has written. And class 2 I will explain next class. Just one another some example you can see here. Class 1 lever, all fulcrum middle. Suppose this spade turning soil, you can see fulcrum middle. Here is the hard soil. Here soil means it is the spade. Okay, spade means, so you know, everybody use it to turning the soil. Okay, you can see hard soil, we are using spade. Here is the load. Okay, Bengali you can say kodal. Okay, that is thing. Effort we are providing here, fulcrum middle, load is here, that means it is a first class lever. Fulcrum middle, you can see spoon used to open a lid, spoon. So here is the fulcrum, the job where the portion attached with the main thing, that is the fulcrum. Here is the load. Okay, that cork is the load, lid or cork is the load, and here is the effort we are providing here. Seesaw, crowbar, I told you, that is the scissors. Here handle of a water pump, you can see. You just remember where the position of fulcrum. Okay, middle, there is the joint means middle fulcrum, load this side, effort this side, that means first class leader. Crowbar, here is the fulcrum joint portion, so load this side, effort this side. Where we are giving our work, our effort, that is effort. Okay, where you are doing, just think on like that way, that where I am doing the work by using, suppose you are doing work by using that instrument, then you understand effort you are giving one place. So where is the joint, fulcrum and load, check about where the load and where is the fulcrum. By using that place with your concept, you can understand is that a first class or second class or class 3 lever. Students, now just one short concept I explain here, that what is that velocity ratio. That is easy, very easy. Students, mechanical advantage, you know that load by effort. So suppose if that is fulcrum, that is effort, E F, this is L. Okay, so fulcrum to that is load arm and that is effort arm. Okay, so that distance, if you effort arm means that distance multiply by time, you know velocity is equal to d by time. Okay, so de, okay, distance of that effort arm and distance divided by time, that you can say that velocity. Okay, similarly left side, velocity of load arm is equal to velocity distance of load arm by time. Okay, time taken to go here, that ratio you can say that velocity ratio. Okay, velocity of effort by the velocity of load, it will use for some maths purpose, that's why I written here. Okay, so very easy, it's okay. When you zoom, you can see velocity of load, you know, distance by time, and velocity of effort also distance by time. So if you divide that by effort by load, then you can get dE by dl, that is the velocity ratio. Okay, or it will use to understand the third type. You know na, when mechanical advantage is 1, that time that displacement of effort to the displacement of load. In the case of scissor, you can see that the displacement of effort is more. Okay, in that time velocity ratio is greater than 1. That's why it is providing a mechanical advantage. I hope students you understand. Thank you very much. Next class I will explain about second class lever.